Good afternoon, everybody. My name is Chris Bouch. I've been working in our water division for about 12 years now. I'm a licensed engineer. I'm one of the support engineers at the company. So right now, my primary responsibility is helping sales. Supporting our equipment, sizing our equipment, that kind of thing. So this is what we're going to be talking about today is we're going to be talking about equipment. We're going to be talking about how the equipment chlorinates the pool, and we're going to be talking about limitations on how our equipment in particular chlorinates the pool or has the potential to have an overchlorination of the pool. Let me see if I can control these slides. Can I control these slides?
You should be able to.
Okay, I might have you just forward them for me. This screen basically has some information on how the webinar works. And if you need to ask a question at any time, I can pretty much answer a question anytime if it comes over. It also has a raise your hand icon if you have a question and you want to do it audibly or without typing it. You can just simply hit the raise your hand button. Okay, let's go to the next slide. Okay, so we're Sagura. We've been around for a long time. We've been with pool chemicals. We have our current feeder line is about 30 years old. We've been making pool chemicals longer than that under various names. We're the largest producer of cow hypo in the world, and we're definitely the largest in North America supplier of cow hypo. So we're pretty much the main supplier for the industry, at least in this part of the world. Next slide. Now, Pulsar, like I said earlier, Pulsar has been around for 30 years. I've been around for maybe a third of that. What Pulsar offers is we've been making these feeders for 3 decades now. Our biggest advantage is we have excellent support for our units. We don't just sell equipment and, with hands off. We're very hands-on with our equipment. When people are buying it, they can always contact us. A lot of times, if it's a bigger application, I'm directly involved. Sales is directly involved. What our equipment is our equipment is scaled to fit the application. So whatever the body of water is, our equipment is sized for that body of water specifically. So we don't just sell feeders without, contacting the end users. The end users send us or the dealers information. We specify equipment to fit the application. And that's very important, especially in what we're talking about today. We're familiar with all the equipment, all the pool equipment. We supply a lot of different chemicals. We supply a lot of different equipment. So if we go into a pool environment, we understand all the other equipment involved. We understand SCADA, we understand chlorine controllers. I personally designed SCADA systems for the past 12 years. We have 2 people on staff that are designing a chlorine controller specifically for pools. So we have a very good understanding of how pool controls go, how we add chemicals to pools, how they need to be added, what needs to be added. So we're probably top of the industry as far as understanding with our team about how we need to treat pools. We have a support center. If anybody needs to, anybody has a question or rudimentary question, they call the support center. Support center can answer most questions. If they can't answer it, they'll forward it to one of us engineers, and we'll get in contact with the end user and answer their questions or address their concerns, or if they have a suggestion, we're always open to suggestions. So we're good that way. Next slide. Here's our history of our pulsar feeders. I've seen all of these in the field. I came in pretty much in the middle there after 2003 and before 2013. But when I came in and started working for this division in 2009, we were working with those first 3 units. So familiar with those, and then familiar with the units after that. I was directly involved with the units after that. So our team, I've been directly involved with the design team for all the pool equipment and design versions of equipment myself on the industrial and water treatment side. So we've been around for a while. This equipment's been around for a while, so we have a wonderful understanding of how everything works in the pool environment, works with other chemicals. Now, we're going to talk about basically what we're seeing in the industry and what happened down in Texas. Basically, they had an uncontrolled chlorine dosing. It involved bleach and acid. So basically, we don't yet know the sequence of how it happened, but they overdosed bleach and acid at the same time, which people familiar with the chemistry know that once you mix bleach and acid, you get a liberation of chlorine gas into the environment. So the acid actually liberates the chlorine gas out of solution, out of the water. And you basically get a chlorine gas cloud. The bleach probably also overchlorinated water. So we don't know if it was a slug that went into the pool or whether it was just a continuous overchlorination at this point. I think they're still doing the investigation, but this isn't the first time this type of thing has happened. When I first hired on in 2010, there was a very similar incident. Not as bad. Wave pool. Kids and adults were complaining about their eyes burning. Ends up they just left a bleach pump on, and the bleach pump just continuously pumped at 100% capacity until they had to evacuate the pool. People were hospitalized in that incident. In 2014, there was an incident at Michigan Adventure, very similar to this one, not quite as bad once again, but there were hospitalizations and there was chlorine gas inhalation. So basically, it was another over pumping of bleach into the system. Per the CDC, you can see the symptoms of what happens when they're exposed. Mainly what you hear about in these news articles is there's either their eyes start burning or they have a hard time breathing. They're coughing because you're either dealing with a highly chlorinated water or you're dealing with actual gas. So the gas is obviously the worst of the two because the chlorinated water will cause, burning of the skin, irritation of the eyes, burning of the eyes, but it's nowhere near as bad as a chlorine gas exposure. So next slide. So we just talked about the water park incident. I think it's up to 100 people now, according to the latest estimate of people that underwent that were needed to be treated either at the hospital or on site by paramedics. They were using pumping bleach and a 35% sulfuric acid for pH control. So, and they're currently investigating, so we don't know the direct mechanism or sequence of operations that caused this, but we can estimate. The initial incident I was talking about, they were dosing bleach into a static line. So all the pool recirculation equipment was turned off in the evening. The bleach pump continued to dose overnight. And then when they opened it up in the morning, there was just a slug of bleach that went into the pool. So we have ways to remediate that with our equipment. Our equipment not only is a much lower concentration and output, but it simply will not pump into a static line. Next slide. Now, this one talks about a month ago, there was a New Jersey incident in a public pool. when I went to look this up, I looked up last year's incident. So apparently in the last year, they've had 2 incidents in New Jersey pools where kids were hospitalized with chlorine exposure symptoms. So this isn't, this isn't an incident that's isolated, and we can, hope that we're not going to see it again. It's an incident that we've been seeing, and it's an incident that you try and engineer your way around, which is what we do. But there are certain engineering controls that we, in particular, apply to our equipment, and we've been applying since I came on board, that we don't see in the other industry, and especially in sodium hypochlorite. Next slide. Now, the difference between our equipment and Bleach is that Bleach is simply ready to go. It's there, it's ready to go into solution at any point when you need it. Now, that's good and bad. The bad part is that you can easily overdose because everything's already in a liquid form. Unlike our product, it's all in solution, and it can all be dosed into a pool on an uncontrolled manner if conditions are right. Now, what conditions a pump sticks on? You can have siphoning depending on the type of pump you're using. Like I put here, a half-inch tubing. Half-inch tubing can siphon 12 gallons a minute. That's 12 pounds of chlorine per minute you can add to a pool. We'll get into what our equipment does, but 12 pounds a minute is quite a bit. A lot of times they're using smaller gauge tubing, but even 1/4-inch tubing, you're still adding a few gallons per minute in an uncontrolled situation. So that's still enough chlorine to cause an incident at a pool. So, and especially if you're going into a static line, that ends up being quite a bit of chlorine that you're adding in an uncontrolled environment. The bleach is up to 20 times more concentrated than the solution we make. So for every gallon of bleach, every 20 gallons of our solution you pump, that's equivalent to a gallon of bleach. So we have a lower concentration, concentrated solution. We have a time delivery system because we're converting a solid into a solution. So we have to actually take the solid and make it into solution. Here, let's go to the next slide. We're going to get into that. The way our system works is that we have a unit, and when it calls for chlorine, it starts making solution. The most our equipment can hold is about 1 pound of chlorine in solution at any particular time under any condition. Once the precision feeder, which is one of our larger feeders, starts operating, the most chlorine it can produce is 1/5 pound per minute. So under an uncontrolled situation, you're only adding 1 pound every 5 minutes of chlorine, which compared to, let's say, 12 pounds of bleach under a similar condition is quite a bit different. Actually, 12 pounds per minute versus 1/5 pound per minute. That is because our equipment, we size the equipment for the application. We take all the information we can, or the dealers do. We only sell them the amount of equipment they need, probably double what their typical application is on a pool. So we'll figure out what they need with some equipment that will only do double that in a period of time. Let's say they need 10 pounds a day with some equipment that provides 20 pounds a day. So even under worst condition, they're only dosing twice what they need, which doesn't lead to hospitalizations, at least over-chlorinating, but it happens over a longer period of time, and it's easier to catch and easier to control. So our equipment size for the application on a larger pool, let's say a wave pool, we might have 3 or 4 units because it needs 3 or 4 units to operate at 50% capacity. So if they're dosing 2 ppm and it goes out of control, we're suddenly dosing 4 ppm. For instance, a Pulsar precision feeder on a 200,000 gallon pool, it can only raise the ppm raise the concentration 7 ppm in an hour. So if let's say it goes in an uncontrolled situation, suddenly after an hour, you're 7 ppm higher than you would normally be. in that pool, which is not a, it's not a, you know, you're not burning anybody. It's not a life-threatening situation. By the time, you know, they catch it, they'll start smelling chlorine over, you know, several hours, and then they'll catch the incident, or the pool controllers will catch the incident. The problem with bleach is it can overwhelm a control system. It can add so much chlorine at one time that the control system can't even, you know, catch up. By the time you get an indication that it's over chlorinated, that there's too much chlorine in the pool, a lot of times they've already added so much chlorine, we're in the middle of an incident. Our system can't do that. Our systems, we're adding a fraction, a tenth of a ppm per hour, so, or per minute, let's say. So it takes a while for that to accumulate in the pool. Okay. Here's a basic cross section of our unit. You can see the solid chlorine goes into that yellow hopper in the middle, the basket. The majority of our chlorine is stored in a solid condition at all times. So if you add a pail of 50 pounds of chlorine, you're only going to get, once again, a half a pound in solution at any one time. You're only being able to dissolve a fifth of a pound every minute. So it takes a while. You know, it would take, what would that be? 250 minutes to dissolve that. So you got 250 minutes to add 50 pounds of chlorine, which is what, 4 hours, compared to bleach, which could add, you know, as you know, can add quite a bit more. Next slide. One of our safety features that we've implemented in our systems for a long time is we're using a Venturi to inject the solution into the treated water. The advantage of the Venturi is basically, once you have water flow through the ends of the Venturi, you get suction. So you're adding chemical. Once that flow stops, all pumping stops, all chemical addition stops. So once everything shuts down in the evening, all the pumps shut down, you don't have any more chemical addition. You can't even have any more chemical addition because it's impossible. It's impossible for this type of a system to siphon. How do we, another safety feature that we have involved is we have a flow switch. So sometimes our Venturis are run off a booster pump, which is connected to the main pool recirculation system. That booster pump is controlled by two interlocks. It's controlled by a flow interlock on the main recirculation system, and it's controlled by a redundant interlock with the pool pump. So once the pool pump goes off, the system shuts down. Once there's no more flow in the line, the system shuts down. So both of these can shut down the system. So it's basically, it's the fail-safe. When we're adding chlorine, when the pool calls for chlorine, it turns on the booster pump and it adds chlorine at a very controlled rate. Once it doesn't need chlorine, it stops. There's no speed adjustment. There's no way for an employee to turn the system up to a higher rate than it's needed, because it's only got one rate. And the rate is set at pretty much what your pool needs at that particular time. A little over that so it can catch up, but it's not set at a unlimited rate. So if there's an oversized pump in a bleach system, you could set that whatever you want if you're trying to catch up. But on our system, it only adds one rate. It adds chlorine until no more chlorine is needed, and it's adding that at a fifth of a pound a minute. So next slide. This kind of reiterates what we've already talked about. There's a maximum feed rate on our equipment, and it's size for the pump, it's size for the body of water, size for the pool or the water feature. So you're getting pretty much close to what is needed every time it turns on. You're not getting a controllable dose that can be manipulated. There's absolutely no way to get chlorine in at an advanced rate with our equipment, because once again, we're dealing with a solid that needs to go into a solution and it needs to dissolve, and that's all all those physical characteristics control the amount of chlorine that can be added at any particular time. And our equipment is sized, once again, it's not oversized. If we're, for some reason, a precision feeder is too big for a water application, we'll go to a smaller feeder. We won't sell a piece of equipment that's too big for the application. So our equipment is sized for it, for the particular applications that they're going to be used on. And there's limits to that. Next slide. Here's basically an overview of the Pulsar Precision. It's like I said earlier, it's probably, you could probably do up to a 300,000-400,000 gallon pool with this particular system. So depending on load, if it's a high load, you'll probably need 2 systems. If it's like, for instance, I was at a wave pool in Oklahoma and we added 4 of these, but it was a 1 million gallon wave pool. So, and 4 of these would, you know, would easily keep up with their application, but it's not oversized. We didn't sell them 8 because they needed 4. We sold them only 4, and they maybe can run off of 3, and they probably do need 3 to keep it chlorinated. So they can take 1 offline, but we're not at an excess capacity. We're not bringing in a truckload of chemical that can be added at any particular time. Everything's controlled, and you're also having to add briquettes. So adding the briquettes also controls the amount of chlorine that's even available to go into your system. So if you have a day's worth of chlorine in your equipment, you have a day's worth of chlorine. You can't add any more than that because it's in a solid form. And this is just basically goes into the advantages of our particular Cal Hypo system. So we're using an erosion system that basically erodes a 1-inch bed, 1 inch by 6-inch circumference bed of chlorine briquettes. And that's how you make your solution. So it's a controlled area, it's a controlled size of the area being wetted, it's a controlled amount of chemical in the system at any time, and it's a controlled feed rate. Okay, next slide.